hi Lakshmi. Hey, good morning to all of you guys. I can still see 11 people are missing. We will start in next 2 minutes then.
Yes, sir. So guys, just wanted to check, is Docker installed on all your machines?
Yes, Girish.
Last 2 minutes.
Yes, Girish.
Okay,
Yes, Girish, it is installed.
Perfect.
okay.
Be able to then do a lot of practice, which I will give you. Let everyone join. I will tell you the format also, how it's going to be.
Actually, this should be the site. There was some issue with my installation. Actually, yesterday I installed, but when I try to open, it says Docker engine failed to start. Then IT team also, Irana also tried looking into it, Girish, but he couldn't do it. He said he'll try today.
Okay, then I'll speak to Irana. Sorry.
Yeah, no, I'll already, I already set up call with him, so not required, but just FYI, it's not installed for me. I actually
Okay.
tried a couple of times myself, and then Iran also tried by screen sharing, but it didn't happen.
Okay. So guys, is it only for Surbhi or anyone else had this issue?
Even I'm facing the same issue, Girish. She told she'll connect today and fix it. Like, there's some issue with the Linux base package
Yeah,
or something. It's not downloading.
right.
Okay.
Same here for me, Garish. It is actually showing like WSL2 installation is incomplete. So it is kind of a WSL Linux kernel. It is asking to install again.
Okay. Oh, okay, guys. We'll take it offline. I'll speak to you.
So quick input, when the pop-up comes up to install the WSL2, there's a link on it. If you go to that link, you'll be able to find the installer. I can let you guys know after the meeting. Send an email.
Yeah, I tried even that, Arun. I don't think that happened, but yeah, of course, let's talk again after some time. All of us who have problem, let's get into call after the training, and then we can sort this out.
Okay, so even one more thing is if you're not able to do out also right now, it's okay. You can do it even afterwards. That's not going to be a big deal, but it's just that I will be giving you some of the things which will run on Docker. And you can also do it in non-Docker also. I will also show you non-Docker base as well. The intention of just introducing Docker for you was to kind of give you a reference that how exactly this will look like in the real world when you are working and how clients can give you their own Dockers and how you can proceed with that. So do not much bother about it. I have both the things ready with me to kind of showcase you, but it's if you have it, it will be better. That's it. I'm not able to open the participant list today for some reason. Okay, now it opened. Now, one thing which I want to convey today, which I will also be kind of going across till tomorrow. So today we are going to discuss majorly on Spark streaming. We will be spending some good time on it. Unfortunately, my laptop crashed today for some reason. Some JVM issues and all that started happening just before the class. So anyway, this will not impact today's session, but I had something planned for today extra, which probably I cannot bring up. Maybe I can talk about it tomorrow. I have to still fix my laptop then. But yeah, for today's session, there will not be issue. I just arranged something for that. Talking about another thing, so we will be starting with some Spark streaming concept. We will be moving after that to Spark MLF. And then we will be talking about a bit on Dockers quickly to give you a reference on that. And then we will be moving on Apache Kafka. That's going to be the precedence way. Now, as I told even yesterday, Apache Kafka is a course in itself. It's pretty huge. Means I have taken sessions for complete 3 days only on Apache Kafka. So it is almost impossible to bring up every component in that. So the idea would be I will be explaining you how Apache Kafka works, why we use it, where we use it, why basically we prefer to use Kafka streaming over, let's say, Spark streaming or vice versa. I will also show you code, how we go across creating some producers, consumer, and how you can even do all these things without any coding using something called as Kafka Connect. But apart from that, what I'm doing right now, I'm still writing some code for you guys. Maybe I will give you more on the code part with everything written down in it. And from that code, it will be step by step. So I will be performing all the steps in my machine to ensure that every step is working. Anyway, I'm writing it up and testing it across along with it. I will give you all that. So maybe that would help you to do some more advanced stuff. Okay, so you can play around with that and go about it afterwards. So it will be written in a very easy English way so that you can understand and go about it. Because otherwise, it's a pretty lengthy topic. In fact, generally a separate sort of training is sort of recommended for the same topics and not being mixed with this Hadoop and Spark because this itself consumes a good amount of time. But I will give you some code base which you can probably walk you through after that. Okay. Now, let me start with Spark streaming. So yesterday we have basically discussed on few of the components which included Spark SQL. We saw some Spark SQL topics, how we work across with it. Then we also have seen after we have covered Spark SQL, we went to Spark streaming. Now in Spark streaming, I explained you a few concepts. For example, the first thing I discussed with you is a D stream. The D stream was when we were just sort of looking at the mini RDD, or you can say mini batch RDD, that is for let's say few milliseconds, few seconds, or whatever time frame we want to give it to. So once we got the smaller data and we created an RDD out of it, we will be sort of able to create these streams out of it, and these streams can run in parallel across to multiple machines and thus make Spark streaming quite stronger. We also noticed that Spark SQL is pretty good to deal with the strat mode. So basically, if any machine is working slow, Spark streaming is pretty good to take care of those situations. It will immediately send that D stream to another system and get your task done quickly. And all this happens at the backend, which you need not bother. In fact, this is one of the very strong thing in Spark streaming. This is not there even in Kafka streaming or Storm. This is one of the strong reasons why people even prefer to go with Spark streaming a lot of times. Now, second thing is that when we talk about Spark streaming, there are some sort of basically timings. For example, I said we create mini batch of data. So what is that? That is called as batch time for you. Similarly, we can also perform windowing operation. That's where I explain you something called as there's a sliding window. That could be something like, okay, what is the window size which we want to go with? Like I gave you an example also for that for example, my batch size could be 1 second, but my window size could be 10 seconds, right? So in that 10 second, I will have 10 batches of data in that case, 10 D stream of data in that case. And then we also saw that there is something called as sliding window time. So the time which we talk here is that with what time frame we are moving it. So let's say if we say 2 seconds, it means that keep on moving that window of 10 seconds by 2 seconds every time. So that's what is basically, there are some timings across which we will be discussing today. Now let's take the first example and we will see how we will be working across with respect to Spark streaming. So what I'm going to do in this case, first of all, I am going to pass my data from a terminal. So there are ports in the system, just like you are living in an apartment, but inside your apartment you have an apartment number, specific apartment number. Same way, when you're working with Apache Spark, you also have some ports. So you can write the data also to that port and can do any operations as per your wish. So for example, like we have a port 1234999, and we have seen it, right? Even when we were discussing about Apache Spark, we saw the port 4040 or 4041, right? Similarly, for Apache Tomcat and all, you have ports 8080, right? Like this, we have port number. So some ports are reserved for few items. We should not be using those ports for writing stuff because otherwise it could have problems. So better is to open a port where we can write the data. Now, how we can write a data? For that, we have something called as a netcat utility. Okay, so netcat utility help you to write the port. You can lock it, and then you can use it for writing purpose, whatever you want. So I can open it by saying nc-lkv. It means lock my port and make it available for whatever writing you want. And I want to open the port number 1234. Definitely, you need to give the valid port. It's not possible you say 999999. There's no port like that, right? So the ports, you need to give a valid port. So let's say I give this. In case if it's already occupied, it will throw me an error. So right now you can see when I hit this, there is nothing happened because now it's ready to write any data or even read any data. I'm not going to do any reading for now. I'm just going to write something on this port. Now, what is the second thing I'm going to do? As in, since I have opened this port, I need to have my Spark streaming program. Now, number one, in order to work on Spark streaming, just like you have Spark context, you have SQL context, Hive context. Similarly, to work on Spark streaming, you have something called a streaming context. Now, streaming context is also dependent on Spark context. Okay, that's one thing to keep in mind. Now, how we will be working here? So first of all, we need to import some packages. So I will say import org.apache.spark.streaming.underscore, which means inside this package, whatever is there, get it for me. Okay. So this is the first import. Second thing you also need is within streaming also you have a directory. So it works something like this. So let's say you have a directory A. Okay. Now inside this directory A, you could have some files, maybe a.txt, b.txt, a.conf, b.conf, and you could have directories also, right? So you could have, let's say, a directory B within A, right? That's another directory. So what happens is when you're importing this, the data which is present in this directory B will not maybe show up to you. It will just show you that, okay, I have a directory B. But what is present inside this B, which could be c.conf, d.conf, that will not show up to you. That's the reason what I have to do here is, even here, yeah. So I need to again import this also. So what I have to import? So inside streaming, I have something called as streaming context that you can think of it again like a directory. That was just an example for you. And inside that, whatever files are there, I need to also import it. So that's the second step. Third step is inside the streaming, there is also one more thing called as seconds. This is related to more on the timings part to provide the batch time, serial time, and so on. That is what I will be doing with this. So these are the three imports. First of all, you need it. Second step. Once I'm done with this, now I need to create my streaming context. How I will be doing that? So I will say, let's say val ssc is equal to new. I'm going to create a streaming context. So I will say streaming context. And when I'm creating the streaming context, it is dependent on my Spark context, number one. And what is the batch size I want to create with it? So remember the batch timing, like what would be the size of it? I'm giving 5 seconds so that at least we can see some data coming in that. Or even if I would have wanted, I could have given 10 seconds also. maybe let's make it 10 seconds so that we can have a good amount of data to be seen. Now I will execute it. So this is going to create a streaming context for me. Now, since I have opened the port 1234, that means I have to tell my Spark that I'm going to read the data which is sitting into 1234 port number. Now, in order to do that, I need to open something called as a socket connection. Okay, so that is called as socket text stream because I need to bring the data from there. So how I do that? I will say val. Let's say I'm going to call it as val my stream is equal to my streaming context dot. I will be calling it as socket text stream. Now, where I will be doing it, this is going to happen on my local machine. So I'm going to call it as localhost. Okay. Now, once I'm done with this, I'm going to call it as 1234 port number. So as soon as I will do this, right now it will say that, okay, I'm going to create a connection with this using a socket, and I'm going to bring some text data from that. That is what the thing it's going to do for me. Now, once I'm done, what I want to do now. So this is all about just understanding the streaming context and all. But what we are going to do in this particular program. So in this particular program, I want to do a word count. So we have already seen word count on the batch data. But now what I want to do is, I want to do a word count with respect to, basically you can think of this word count with respect to the batch time. So whatever data I'm getting in those 10 seconds, only for that 10-second data, do the word count. So then after that 10 seconds are over, whatever new data comes up, for that again do the word count. Okay, so that is what we are doing in this case as well. Now, how I do it, this is we are well aware of how we perform all these operations. So we can say, hey, val words is equal to, I'm going to take this my stream of data, which is going to get from this port number. I'm going to say flat map. Now inside this flat map, I can say, let's say line, arrow line, dot split. Maybe I can space it with respect to word, or I can give a space, whatever, right? So this we are well aware of anyway. There's nothing new inside it. So this is the code which I'm writing. Now number one, right now it has not got any data. It's anywhere transformation step also for us. There is no data it have got. So there's no step also which is going to happen right now. It is just going to be right now sitting, creating a lineage for me. And later on only all the executions are going to happen with this. So let's execute this one also. Once we are done with this, let's execute one more. So I'm going to say word counts, and I'm going to say words dot map. I can simply say, let's say word arrow, and I can define it as word comma one. This is what we used to do, right? So we define it as word comma one dot reduce by key. Now here, what we used to do, we used to give two variables, arrow v1 plus v2. Okay, that's the next step. So what I've done,
Shiva, V1 plus V2.
oh, thank you. V1 plus v2. So we have just basically went ahead and created this word counts right now, which is going to be the same code what we are well aware of. There's nothing new we have done here, right? And you can see right now it's also not doing anything. After that, what I want to do, I want to print the data. But right now I have no data, so nothing will happen. So we have to start it after that. But for now, we will say word counts dot print. Now what this is going to do, once my streaming program will run, it will start printing all the data for me. Okay, that's a step it will perform for me. Now how to start this? I will say ssc.start number one. And after that, I will say ssc is the streaming context, right? Await termination. This means do not stop this program till the time I do any operation for it. So now it have already started. You can see it's running something. Let me put down some data. Let's say hello, Shivang. Hello. Let's see the output first. Can you see what just happened? I got hello 2 times, Shivang 1 time. Now let's wait for 10 seconds time frame. Let's say one more hello. Now you should see hello comma 1 in the output, not hello comma 3. Why? because in the next 10-second window, I am basically going to treat hello as a complete new record, right? I could keep giving some more data like A, B, 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 B. Let's see this output now. Can you see this part? So whatever data you got, now after that, if you give some more A's, it will be not counting after 6, but instead it will be counting it as a new one, as you can see A, 3. So this is how you can see that we can perform a simple Spark streaming stuff. Everyone clear first of all with this example?
Shivank, how long can a port be open?
You can keep it open for how much you want.
There is no TTL
No
for a
TTL.
port.
I can do a control C and close it. That's another thing. But otherwise, no. Right now, can you see just waiting? Okay, give me some more data.
Okay.
Then otherwise, you can see all this blanks window will keep coming up. Every 10 seconds, we have a blank window as an output. Everyone
Okay,
clear?
sure.
Everyone clear on this? How this works? Okay. Now go ahead, and what I want all of you to do now is, I want to add one more step to it, which you have to perform. So what I want is that basically I want to do a word count, but one condition with it. In case if that word count have your name coming up, let's say if Arun is running the program, and let's say if Arun gives from the netcat Arun, then that word should not be considered into the word count. Okay, so that is what I want as a program. I can show you this code. Let me close this, take you up. So this code is in front of you. You can run it because I don't have anywhere written. I just wrote it on the fly. So I give you this code, but now you have to tweak this code to make it work, which allows all the word counting except your name. So if Arun types his own name, let's say just like how I wrote Shivang, it gave me Shivang, 1. But in case if I have, let's say, done that change, then it should not have considered Shivang at all. Clear, everyone? Now, can you all do this? Keep the batch size window to 5 to 10 seconds, whatever you wish. If you want, you can play with 1 second also.
Shivank, I might have missed it, but what is this? How have you opened this right-hand side window with this port number 1234?
I just did this netcat, right? NC-LKB 1234. This is the command input.
So while connecting to Spark Shell, do we have to mention the port or simply Spark hyphen shell?
No, so you can open 2 terminals, right? It's just like opening 2 notepads in one laptop. So open at 2 terminals. In one terminal, write this netcat thing. In the second terminal, go and log in with your Spark-shell.
Okay.
But you're clear on the problem, Karthik, right? What you have to do?
Yes, I am clear on the problem.
Whoever writes it, please send me on the chat, but on a private chat, not to everyone.
Shivank, it is giving me an error that percentage NC, no such job.
No, sir. Is it completing netcat is not installed with you?
No,
Where are you running it?
I'm running in my Cloudera shell.
Okay. What about others? It should work. In
I
Cloudera,
didn't
this
have any issue, Shivank.
for you it's working, right? Okay. It should work. Just see if you're typing wrongly or something, Karthik. You have to say NC hyphen space LKV space 1234. It should work
Okay.
because system
Okay.
network is available. In case it still do not work, go to your cloud log.
Shivank, can you check what is wrong in this command? I'm just trying to import the context, streaming context.
This should also work. Just see if this is being sensitive. And are you also running on the Cloud Lab?
Yeah,
Cloud Lab or this one? Where are you running?
no, the VM, Cloudera VM.
Let me open that.
Should I do it in Cloud Lab?
You can try it there, but it's maybe a typo because I've already tested it on Cloud. It works there. I can again open and show it to you guys. Meanwhile, you can go and try that.
Shivan, could you move this a little bit to the right so that I can see the command?
Okay, sorry, this came in front of your commands. You guys can see it from here. Anyway, this till this step is only important. After that, you can write. So first of all, Karthik, this is for you. You can see Netcat is working. Okay. Even this is working. This is the same VM which I have given to all of you.
It's working now, Shivank.
Maybe I've done a typo or something. Karthik, you are able to fix your netcat issue, right?
Yes, Shivank, I'm able to run that now.
Okay, then closing this machine, guys, as it eats up the RAM.
Shiva, what does the termination method do? Can you say that again?
Control C.
No. You put in a function, right? Terminate or something.
Uh,
Termination.
This-
Yeah.
Await termination. So you have to say, let me write it here so that you have it. You have to say basically SSC dot await termination. Sorry, there's a typo here. Just make the spelling of await correct. AWA.
Right.
Make sure that while testing you pass the name of yours to see whether that is fixed. Last 5 minutes, guys, quickly complete it and send me your code. Have you guys completed it? Mean guys, you guys were doing it. I just wrote this code here in your Google Drive so that you can copy paste if you are struggling to get any sort of syntax. I just passed on the link on the chat for your Google Drive. You have to just add one line to it, which is going to be a filter statement, and then it should work for you. That's it. Last 2 minutes quickly completed. Now you have the syntax of the.
How do you stop it? I'm getting some error.
Just do a Control C or Control J.
Even on the Spark stream part, it's not working actually.
It will work with
It's
Control C.
continuously throwing error, heartbeat error, something. No stream
No,
in 10 seconds.
it should work. Either close the terminal itself or restart your system once. Since you have the syntax, you can just quickly copy paste now when you restart.
Shivang, when you hit the ssc.start command, it starts the streaming, right? When do you hit this termination command?
This is actually more required when you're running it through Eclipse. So what we are telling from this await termination is we are telling it that do not let the program quit on its own. It should be quit only till the time we terminate manually, like doing a Control C or Control J.
Okay. So when I hit this ssc.start command, it said dynamic allocation is enabled for this. Yeah, if write ahead log is not enabled for non-replayable sources like Flume. Some error. It's a long error. Just trying to give you the keywords. Initial job has not accepted any resources. Check your cluster UI.
Can you go to Spark UI and check there what's happening there?
Okay.
It should work because this program I've tested it on your Cloudera VM only. Though I'm showing it here, but I ran it on the Cloudera VM. If you are running some other processes on your laptop, just stop it for meanwhile because it definitely needs some extra RAM.
So I just restarted this morning because of the Docker thing. So nothing is running apart from this.
So just stop your Docker because Docker
Okay.
also eats your RAM. It's running at the background. Last 2 minutes, guys. You can now copy paste, guys, to quickly do it. I wanted at least you guys to write one code. After that, it will be mostly me speaking. I will give you minimal stuff to write. Last 1 minute. Okay. Guys, you can just try it afterwards then. Just make sure but you do it. If not able to do that, please ask me tomorrow, because again, you should at least know how the streaming things works and all that. Now, what I want to do as the next step is, we will be looking at, let's say, if I have to bring the data from Kafka, this will be useful because I also have a program even in your Kafka side as well. Sorry, from Twitter. I want to bring the data from Twitter now. This is warning. This is not an error. So, okay, this is not an error.
Yeah, but whenever I'm typing something in the board in C, I'm not getting the count. I'm just getting this warning every time I hit enter.
Okay, just
Anyways,
try
let's
to
continue with the class. I'll look into this later.
just try that. In case if it do not work tomorrow, maybe you can share your screen. I will ask Lakshmi to enable it, and we can go over maybe 1 or 2 machines.
Sure.
Okay.
Okay.
For now, what is the next step is, let's say if I want to bring the data from Twitter. Okay, let's say I want to build some application, something like from Twitter, and can sort of do the streaming for that. So for that, what all we need to do, I'm not going to show you the complete execution and all that. If required, I can maybe show you tomorrow quickly, but I want to at least show you how those codes are written. In fact, Twitter use Spark streaming for doing this. So that's the reason it will be more interesting for you to see that. Similar kind of program, I would also bring it during the Kafka also. So it will create a good connection between them. That's the reason it's good that I show you right now some Kafka things. Sorry, some Twitter thing. So that once we move to Kafka side also, you have everything with you. Now, in order to bring the data from your Twitter, you need definitely some Twitter API. See, when you have to authenticate from your Twitter, so it's not like you can authenticate from my account, right? You will be able to only authenticate from your Twitter account. Now, the challenge is that when you have to authenticate from your account, uh, whether you should provide your username and password? No, we don't provide username and password. Instead, what we do is we sort of authenticate with the help of some key, which your Twitter provides to you. What are going to be those keys and values which you need? In fact, it provides you 4 keys. One is called as consumer key. Second is called as consumer secret. Third is called as SS token. Fourth is called as SS token secret. These 4 values, you can think of it just like your username and password, but they will be in a hash format. So anybody even reading it will not be able to make out what's your username and password. Just to give you the idea, it will look like this. Okay. So for example, I have put all this down into a twitter.txt file, and you can see I'm giving consumer key. This is the one. Consumer secret. This is the one. SS token. This is the one. SS token secret. This is the one. Anyway, I've removed all that now. You can change these keys also. It's not like it stay the same. So basically, this is the way it will look like. Now you can make out from this, nobody can make out my username and password, number 1. Now, how I can get this key? That's another question. For this, what you have to do is you need to go to a link called as developer.twitter.com. This will look something like this. Okay. So you have to go to developer.twitter.com. Can all of you quickly open this? If you have a Twitter account, can you quickly log in with this so that I can quickly show you how you create an app? Go to developer.twitter.com, log in with your account. I'm sending this link here in the chat so that you can directly go there. Everybody able to see this page now? Means you will not have these apps, but at least you should be able to see this much. You're able to go and see all these use cases, products, docs, community, and so on. Once you're inside, let me know quickly. And I'm assuming everybody here have a Twitter account. In case if not, you can create one, because this will be an interesting exercise if you want to do it later. I will show you how it works and then you can try it later. Okay. Now, once you are inside it, you will see this button, create an app. You can click on this also and get here. Okay. This apps button also you can click and get here. And once you click on create an app, so you can see it's telling me you may continue your existing app, but you can create a new app. Please apply for the developer account. It do take some time. In case if you have to apply, they will ask you some details around it. You have to give some justification also. Write a proper justification, otherwise it get rejected. It takes some half an hour to get your account. Okay. So for me, it's already there. So I'm going to use my older apps which I have. But you can do it later. Don't do it now itself, guys. Do it later. So for me, I'm just going to go back because I don't need to do all this. I can go to my apps. So not apply. So I have already some apps here, right? Now let's say I can go to any app, let's say Shivank one. If you go here, you can see some details being given here, right? It may be example of Twitter with R. I was trying to do this. You can see this key and tokens. Now here, you will be able to see the API key and API secret key also. I can regenerate them also. Like whenever I want, I can refresh them. Then the older key will stop working. Similarly, you can also see the SS token here. Means if you do this, it will start showing up. It will start showing up. You have to regenerate because it have got expired for me. If you regenerate, it will start coming up once again to you. Okay. So this is how you will be able to get these 4 things which I showed you from here. Once you get this 4 hash values, you need to place it in the twitter.txt. First of all, till this step, everyone clear? Okay. Do not apply for app right now. You can do it later because I don't have that much time right now. We have to respect the time as well. But I just wanted to show you how the portal looks like and how you can log in and create an account. It will take some time for you to get that. Now, next step, how to work with this. Let me show you the first one, which is going to be a print tweet. Okay. Now, in order to work with this, what I'm doing is I'm first going to set up my Twitter. For setting up my Twitter, I have created a file which is called as utilities.scala. Now, in this case, what basically I have done in this case, I'm doing 2 things here. Number 1, I'm doing some logging portion. Logging is basically nothing but we have something called as log4j. Now, what is the log4j? Log4j helps you to generate the log of your system. For example, by default, the log level is always info. Info means if you're running, it will show you every activity what Spark is doing. Okay, so keep logging all that into a log file. Second is called as warning. So whenever in your program you will have warning, then only show that warning. Don't show me everything. Third is error. It means that if any error comes up, then only show me that. Otherwise, don't show me anything. That is the third level of the things. So now in this case, you can see I have basically these 3 up. Basically, I'm setting up the level of all this and I'm setting it to error. Okay, that is what I'm doing. No need to go into much detail about that. This is just an idea. Now remember, I was calling this setup Twitter. What is this? Let's see that. Number 1, I'm reading this file, which is twitter.txt. If you recall, twitter.txt have my SS key and value. What I'm doing after that, I'm doing separating it with respect to space because you can see the delimiter I have put down as space here. And if my field length is 2, which is anyway going to happen, which because I've only written it, then in that case, there is something called as omni auth, which is for authentication. Okay, so you have to just provide that. You have to say twitter4j.oauth, which is called as omni auth, and provide my field 0. Field 0 is nothing but going to be your first name, which is let's say consumer key, and then comma fields 1, which is going to be this. So like this, it will pass all the 4 values and authenticate your Twitter account. So this is what exactly this is done. So what I did, first I created an app. From there, I got 4 different values. Once I got 4 different values, I placed it there. Once I placed it there into a TXT file, I created another file where I'm just using it for authentication. That's what we did. Now let's come back and see what I'm going to do from the Spark streaming perspective. Now here, what I'm doing is, I wanted this basically to be running on my local standalone. I could have changed it to Yarn client or Yarn cluster also, up to me how the configurations are being set up. And I'm giving the name of this as print tweet. This is the name for that. And here I'm passing basically my seconds, which is going to be the bash thing, which I want. So I am taking 1 second because when you're logging from the Twitter and getting the tweets, it will be too much. Okay, there will be too much of tweet in 1 second, which will come up here. Now, after that, I'm doing setup login. Again, the setup login we already know, right? We just saw that you can define all your, basically the error only I want to see. I don't want to see anything else from that. Now, once I'm done with that, now look at this part. What I'm going to do. Now, there's a slight difference from the last streaming program. That's what I wanted to kind of notice here. So first thing is, I'm going to use something called as Twitter utils. This is something provided from the Twitter jar. So I will also give you some 2-3 jars which are specific to streaming Twitter. Okay, so that jar basically have this, and you can see here I'm also doing this, right? org.apache.spark.streaming.twitter, right? So that's what basically have the Twitter utils with me. Now here basically you will have the create stream. You will pass a streaming context which you have created here, and that's it. Don't give anything after that. It's on for now. Actually, otherwise, if you want, you can pass some configuration settings, but it's not required here. Then after that, this is a simple Spark code. So what I'm doing, whatever I'm going to get, basically this tweet. So this tweet, what I'm doing from Twitter stream is going to basically just create the D stream of the data for me, which is for every second. Once I got this D stream of the data, what I'm just telling it, okay, this status, or basically, sorry, this tweets which I have got, this tweet is like an object. It have no data as such within it. It's just an object for me. And since it's just an object, I cannot read it like that. So in order to read this object, I need to read it one by one because it will be like multiple objects, right? It will be like one tweet, second tweet, third tweet, fourth tweet. So that's the reason I have put this status, arrow status. This is for iteration. And then I'm just converting it to the text format because otherwise it will give you the address. It will not give you the data. So you are converting it to the text format. Once you got the statuses, which is you are just printing it up, you ran this start, you ran this await termination. If you have all these things set up, your Spark streaming will work all fine. Okay, you can see all the tweets in front of you getting streamed every second in front of you. This is how you can work with respect to your Spark streaming Twitter program. Everyone clear? Now remember I told you my basically something crashed in my system. So what is crashed is that I'm not able to open any third-party tools like Eclipse and all that. Otherwise, I would have shown you this code running on my Eclipse itself. It does that my Eclipse suddenly it just started showing error. Not just Eclipse, a lot of other softwares also. So I need to go and fix that. So if it fixed, I will show you this code running tomorrow itself. I will have it everything ready. I will not show you how I'm setting all these values and all. I will just show you it running, okay? So that you can see all the tweets coming up in front of you. Everyone clear on this? Any questions?
Yeah, Shivang, is there any limit in getting this tweets from Twitter?
There is no limit as such, but yes, for the free account, you have, I think, 2000 tweets or something, which you can bring up per day. Okay. If you go for the premium, there is no limit.
Okay, previous day, no limit. Same day, you can get only 2000 tweets, is it?
Yes. Because they don't allow this for you to use it for too many tweets, because otherwise you can, maybe you're using it for a business purpose. For that, Twitter wants to make money.
Yeah, I had worked on the streaming long back. Back then, it was kind of like only 100 tweets I was able to get. Post 100 tweets, the Twitter was not sending the data.
If I'm not wrong, I have seen till 2000 recently only.
Okay, okay.
We did this program, I ran it, and by mistake I left it for 1 hour, and it did run.
Okay. I know that when you get these tweets, right, you can do some sentiment analysis on top of it. That is what I have done. But apart from that, is there anything else that you have done on this data?
It depends what kind of things you want to do. Definitely sentiment analysis is the major use case what people kind of perform on it. To understand what people are talking about and whether it's positive or negative thing. Uh, they also kind of even try to understand, like this is also Twitter use it internally, like to see if they have any pornographic sort of content coming up or anything which is sort of related to violence or something like that. So Twitter basically also keep a track of all this part, and based on that they take a call whether we should be removing it or having it on the platform.
Okay, so beyond 2000 tweets, we have to pay, and only then we'll be able to get the data. Is it?
Correct. A lot of
Okay.
companies, I have myself bought it once for a client. They were looking for something for the product.
Okay, so
But
what was the cost and how many tweets did you buy?
it was a long time back to be frank.
Oh, okay,
It
okay.
was like no limit. We can have unlimited tweets with that. And the costing was not that huge also. And this costing they don't publish on their website. You have to call them. So I had
Oh,
basically
okay.
to get these packages, and there was some
Mm-hmm.
negotiation. It's not like whatever they say you can go for it. So you
Uh-huh.
can negotiate, and after that they will give you. We got unlimited tweets, and using that
Okay.
we have done the sentiment analysis. But we have definitely not just done sentiment. We have basically bought the package to also got the pictures and videos, which people also upload. And using that we have done some deep learning as well around that data.
Oh, okay.
So we have gone little beyond that step, but we got a lot of images and videos from that.
Mhm. Okay.
Everyone clear on this Twitter example? So guys, see what's the idea behind it. I showed you this Twitter example. Now similar way, there would be some other places also from where you can get the data. From wherever you need to get the data, you need to authenticate them. And wherever you need to authenticate, definitely you should not be passing your username and password. You will be basically every company who says that you can take the data from us, that data basically they will be providing some API for you, just like how Twitter have provided this keys for you. So whichever platform you're taking, you need to just authenticate in the same way how you have done for Twitter, and remaining things almost remain similar. Okay, so the intention what I'm trying to basically bring up here is that you should, when you are basically thinking about any system and bringing the data, this is the best way. Now I can basically bring up one thing, though it was a topic for tomorrow, but still one thing which I want to talk here is when you're bringing the data only for Spark streaming, it is highly possible that you can lose out some data. Spark streaming is not that good. If something is like data is coming with a very high speed volume, you may miss out some data when it's coming to your system. That connection what you have created may not be that great in terms of bringing the data. It can lose some packets in the middle. So that's where what we do is we connect it with Apache Kafka. So what we do is we connect Twitter with Kafka. We bring the data to Spark. Then after that, the processing part we do it with basically the Spark streaming whatever we want to. So what is happening is now Kafka makes sure that you will not lose any tweets in middle. It is basically acting like a connector and ensuring that you always have one-time delivery for you, and you get your data. And then after that, Spark is pretty good for the processing component because you're doing in-memory processing. So that way, this combination works really well. So a lot of places you will have this combination where you will be having a Spark connection with Apache Kafka. I will see if I can bring an example tomorrow, though the time is very limited for that. But in case if I'm not able to bring, I will definitely give you my own written thing, something which you can use it to kind of see the connection as well, how you can create. Because I have in a lot of my project, I do this, combine these two things together, and they work really smart in that. But for this, you need to understand some more advanced component of Kafka also. So that's the reason we will see to this part tomorrow. So yeah, that's one thing which you have to keep in mind to bring any component. Now it's all about your processing, whatever way you want to and go about it. So let's say I give you a question now. Okay. Uh, my question for you is, if I want whatever tweets are coming, okay, I want to find what is the average tweet length which I'm getting across with it. Okay. I don't want you to run this code. Okay. I just want you to maybe write a small rough code for it and send it that snippet to me. What would be a way, what would be your approach if you have to find, let's say, the average tweet length? Okay. Maybe I just interested to find out that what's generally the people are going with the size of the tweet. Maybe there's a hashtag specific going on. Even for that hashtag we can do it, but let's not worry about hashtag for now. For now, just give me the average tweet length. Instead of printing the tweet, it should give me the average tweet length. Can you just write that part of the line, not everything? So can you just give me that? You have 5 minutes. Make sure that you write the code first, and you need not run anywhere. Just show me that code.
Shivank. So the average will be performed based on the batch size or the window size?
I'm basically asking you from the batch size right now.
And batch size is basically what we define in the seconds, right? 5 seconds, 10 seconds. That is the batch size.
Correct.
What will be the window size? The termination part?
So you have to do it in this manner. So let's say you have the batch size 5 seconds. Let's say in 5 seconds you got 10 tweets, right? Now in that 10 tweets, what is the size of the first tweet? What is the size of the second tweet? What is the third size? What is the fourth size? Like this. Got it?
Not exactly. Can you come again once again?
It is going to be like this. So let's say uh, you got a window size of 5 seconds. Okay. So in the last program which I just ran, what happened was I said, okay, in 5 seconds, let's say you got, let's say, 2 tweets. Hello, some word, hashtag, hello, like this. Right? Let's say this is one tweet in that 5 seconds. Second was we are learning. Maybe a hashtag is not there on this. This is then in the next 5 second window, you got another tweet. Let's say you got this time, hello. Second tweet is word. Third tweet is hello world, like this. Okay, let's say these things you got. Then again after 5 seconds, you got more tweets. This is the output which was coming from this program. Now what I wanted was, so let's say in this case, what is the size of this? 3, right? This is the 3 size. What is the size of this? 3, correct? So you could have just done 3 plus 3 divided by 2.
Okay. Okay.
Also, it's going to be 1, then 2. So this is going to be 1 plus 1 plus 2 divided by 3.
Okay. Also, in this case, 5 seconds becomes my batch,
Correct.
right? Oh, what is the window size in this case?
There is no window size. We are not, right now, we have not even started talking about window size.
Okay.
It's actually pretty simple. Instead of just printing this, you have to just basically do the count of them. We have already seen one example of average, right? Same way you have to just apply this. Okay, just last 2 minutes, quickly complete it.
Shiva, can you check? Will this work? What I have done is counting tweets separately and then counting the words separately and then calculate the average. And I'm assuming that one tweet is separated from other by /n.
This will also be fine. Yeah. But you could have done it in one step also. We have already seen.
Yeah, actually, I forgot that part. I was looking for that only by using some, comma one for each tweet and then apply reduce by key. But I kind of forgot that approach.
Sure, no problem. So you can send it Karthik to everyone so that everyone can see it now. So you have to just replace it with a code which will apply the average. Okay. So guys, you have to just keep these small things in mind. Streaming is very simple. We still use the older things only, which we have learned. Only difference majorly come in starting how to create the connection and all that. Once you have that connection ready, you are all done. And generally, let's say if you have to connect with any system, and let's say that is new for you. I just showed you Twitter, but maybe it come up to be, let's say, a very different system. Maybe you're streaming it from some application, maybe some from app, maybe you have bought some API from that and you're doing all that. If you Google it, you will get all that connection code. It's all available. That Spark community is very strong in that. And you will get that connection code, put all that, then apply your code and you are done. That's that simple as this. Okay, Karthik, you can share. Okay, you have shared to everyone. You can look at this. Let me just quickly now walk through since we have no time left to kind of, I can't give you much time on that, unfortunately. So one more thing I wanted to show you is that if I want to print my tweets, which we have already done, but let's say if I want to save my tweet. So what I mean by saving the tweet, maybe the tweets which are coming, I don't want to print them, but I want to save it into HDFS. So in that case, there is a command called as save as text file. So what does save as text file do for me? It basically look at your whatever your tweets you have, and it will go ahead and write it for you. Now, what I will give you this code file, so don't worry about it, how you will be getting all this. So in this case, what I have done, if you look at this part, this is what the tweet I have got till here. This we are well aware of. If I want to just simply dump it into one file, I could have said that save as text file and basically on the statuses, and it will save it with the text.txt folder. Simple file. But in case if I don't want like that, but instead I want to create partitions for it, then in that case you can apply with basically this for loop for this RDD with respect to the time. You can go through this code. It's very simple. I'm again using save as text file only, but this time what I'm doing, tweets underscore whatever the current timestamp is running. So on the current timestamp, let's say I got 5 tweets. So it will save them into one directory, just like in partitions how used to work. So same thing gonna work in this case. Okay. And after maybe created 1,000 partition, I just stopped it explicitly so that it don't keep on running and wasting my space. So I will give you this part anyway, so that you can look at it, how to run all this. Similarly, if I want to, let's say, find out the popular hashtags, think of it similar to what Twitter do, right? They show you the top trending tweets and so on. So for that, what I will do, I will be creating the streaming context. I'm basically creating stream. I'm creating my status, which having all the tweets for me. I'm doing the flat map because I have to do the word count sort of thing. Now here, since it's a tweet, I need to filter all the hashtags only, because in tweets I have multiple words. It's not just the hashtags. So what I need to do, I need to basically get all my hashtags. So I will take out that. Once I get all the hashtags, I will just map it with one. And now look at this. This is a windowing operation now. So what I'm doing here is we are basically doing the reduce by key operation for every 5 minutes. So when I say 5 minutes, so what do you mean by 5 minutes? Remember my batch size was 1. So 5 minutes have 300 seconds. So it will create 300 D streams for me. Means 300 small D stream data for me. And what I want to do, I'm going to keep on sliding it by 1 second. So what is going to happen right now is it will be something like this. Okay. So what's going to happen is, so let's say this is my overall batch. Now I have inside it, maybe let's say 300 these streams of data. I'm not drawing everything. Maybe this is till this point, we have some 300 streams of data. Now what's going to happen? Once this is done, it is going to be now, let's say a new data comes up because we are sliding back 1 second. So what's going to happen? So let's say it reached to 300 1 second. So now in this case, what's going to happen? It is going to take my window till this point. It will ignore this last one thing, and now it will do the basically count of hashtags based on this. So this is how we can do it with just a small change in API. That windowing operation comes with a small change in API. We call it as reduce by key and window. Now in this case, what we are doing, we are doing all the reduce by key steps only what we are well aware of. And notice that I'm just passing that, okay, my window size is 300, which is 300 seconds. And my sliding window is by 1 second. So this, we are just going to keep on skipping by 1 second, and we'll keep on doing the hashtag counts on that. Okay. And remember, this is not one tweet. This means one D stream. So this one D stream could have 5 tweets, 6 tweets, whatever tweets it has. So let's say this, in this D stream, let's say I have 5 tweets. Okay, this 5 tweets. And maybe in this D stream, I have only 2 tweets. So in this case, whatever the count would be, it will be taken up like 3 extra will come up in the red color zone. Okay, clear everyone on this part? How this is working? So this is an important thing to understand from the windowing operation. So I hope now you are clear, because we were not doing this windowing operation last time. Windowing operation now I've just shown you right now.
Yeah,
Any question on this, guys, from anyone?
If anything fails in between, how it is going to handle, Shivam?
Anything will fail in middle, Spark is resilient, right? Remember that. Spark will automatically go and recompute on the other nodes or on the same node itself. That is the reason Spark is preferred all this processing. Now notice one more thing which I'm also doing. I'm also doing a sort by operation. In this case, what I'm doing is, because I need the famous hashtag tweets in that 5 minutes window. So in this case, what's going to happen, I will, based on the count, which is the maximum in that 5-minute window, it will keep on telling me that, okay, this is the top result, this is after that. So that's how, basically, if I'm not wrong, Twitter shows some 10 tweets in the trending section. So you can print out all the 10 tweets like that and show it to your end user. This is almost the similar thing what Twitter do. Definitely, they also have some more complexions with respect to few more things, but this is almost the similar thing what Twitter do in terms of getting the hash tweets. They also use Spark streaming only. They also have Kafka at the initial level from where they bring the tweets to ensure that they don't fail from anywhere. Then they connect with Apache Spark. Once it reaches to Apache Spark, it do almost the same steps. Okay. So this is how Twitter kind of do a real build application with respect to hashtags. You can see the power of Spark now. It's very small code, not very big, but we can do all this computation so easily around it. Now, any questions on this point? Now, let me also tell you one thing with respect to, I think, which somebody asked if something fails. We have a concept called as checkpointing. What do you mean by checkpointing? What Apache Spark do is, let's say you have some operations happening. Let's say operation 1, you have to reach to the final destination. This is, let's say, operation N. Now, in order to reach to this destination, you have to do multiple operations to reach to this step. Okay. So maybe in middle it may create some intermediate data, just like you have map, then you have reduce, right? Because we have lineage for it. So what happens is, it keeps on creating those checkpoints. Means at every temporary data stage, it keep on saving those records somewhere. So like in this case, I'm telling that go and save this check record in this location. Okay, this is what I'm telling right now. So now what's going to happen with this? So let's say after this checkpoint have happened, maybe it have reached to this step. Maybe Spark have reached to this step, and maybe it have failed at this location. So now what Apache Spark will do, instead of recomputing everything from start from here, what it will do, it will go and check the previous checkpoint. So it will get this checkpoint here and will start doing the recomputation from here. Thus, it will make the processing much more faster also. So that is also one thing which Apache Spark do. Okay, to make your checkpointing quite faster in comparison to what basically you can basically instead of going and recomputing everything. Clear everyone on this part also? I hope that this gives you the answer also. I just told you the optimization component of it. One more thing. When you are doing this windowing operation, in windowing operation, one more thing is happening. So recall the same old diagram where I said, let's say you have all these 300 RTTs. Let's say this is your last RTT. Okay. And after that, what happened? You got a new RTT here. Okay. So now what's going to happen with this? This red color will be, let's say, ignoring this, the last one, because my sliding window is this, and will start doing this 5 seconds. Now what it do is, when it have to do the computation of, let's say, adding all this, Apache Spark internally don't add everything from this red color to this. Okay, it don't add. Instead, what it do, just like I told you, right? So here, let's say you have 5 RDDs in this. Okay. In this case, let's say you have only 2 RDDs. So what it do is, instead of doing this computation again, see what is happening now in this red color RDD. We are removing -2, so it will say -2, and we are plussing by +5. So it will say -2 + 5. So which means that it will have +3. So instead of doing the whole computation again, it only concentrate on the, because for all this earlier D stream of smaller RDDs, it have already done all the computations. So that's the reason it don't go ahead and do all that aggregate and everything all together, but instead internally do this optimization of only looking at the specific points what it needs. Everyone clear on this part also? Okay. And again, these optimizations are really smart in Apache Spark. You will not get these optimizations in other tools. So if you basically do processing with other tools and all, there's not as much optimizations what Spark provides. Especially in the processing component, Spark is really very smart. That's the reason Spark streaming is preferred in lot many places. It's just that Spark streaming is not that smart in terms of giving you the guarantee that I'm gonna definitely deliver you this data. That's where only Spark streaming sort of go weak. Now, I will also give you this code, which is going to be with respect to your average peak length. Now, in this case itself, also, if you want, you can also basically create the windows and try that. Take this example. Though this is, I'm just doing like that. You can just look at this. I've basically put down this complete code for you. I'm not going to explanation because again of the time constraint, but you can play around with that. Second thing I've also created is basically some log parsers. I will give you this code also. You can just run it afterward. Now, anyway, you know the concepts, so you can play around with it. So this is about the log parser. So what is this going to be? Just like you have weblogs. Similarly, I have given you some logs here. You can see this is log data, which generally happens when you have, let's say, a server. And then from that server, let's say you're generating a lot of logs. So now this is a similar kind of logs which I created. And from that, this is Apache log. And from that, basically, I wanted to do, let's say, some operation. Maybe I want to find out that how many times, let's say, Apache is offering, how many times, let's say, Tomcat is offering, something like that. So just play around with this, or even this will also help you to get like in my log, how many errors I'm getting, how many warnings I'm getting. So you can put down any sort of points around it. And again, this is a windowing operation. Like if, and this is very helpful. In fact, if you ask me, when Facebook uses it, a lot of companies, Facebook specifically uses it a lot. So what they do is like whatever events are happening into their systems, because they also get into errors, right? So what they do is they keep checking that for this window, if I keep on moving this window with a sliding time, how many times we are hitting error, okay? How many events are producing error. Then they also go one more step beyond and also check that if I talk with respect to a user ID, because when you have a user account there, you have a user ID corresponding to it. So if you have a user ID for this, so for this user ID specifically, how many errors are happening, or maybe for how many user IDs we are getting the errors, let's say per day basis. They want to reduce it. They want to ensure that we kind of reduce that percentage of errors for the users. And that is something they called it as key performance indicator. Okay. So they play around with this, and this is a very interesting thing how they do it. They also collect all these logs, and from that, they just fetch out the error messages, warning messages also. They also see that there should not be much warnings. And kind of, but errors is more critical for them. So they keep a track, and accordingly, they want to keep on improvising for the operational purpose, so that we can reduce the complaints receiving from the users as well. Okay, so this is all about how you can play with this. Again, you can see we calling it reduce by key and window, and it's working for you. Right? So you can play around with all this codes which I'm going to give you. Everything I've run it already. So once I will show you this running, it's super simple. Right? Nothing is complicated here. Similarly, there's a log alarmer.scale also I've written. You can also play with this one also. Again, this is also related to some error messages. Also, from the same log, there are some status codes. Right? Status codes, again, actually this example is also motivated by Facebook only. So they also kind of look at, they have various status code of the errors. So they want to see that how many are success, how many are failure, right? So all those things with respect to status code, because status code, like for example, if you're working in Oracle DB, there is something called as Aura 600. That is called the crash of basically DB. So are we getting those tricky errors or simple errors? So they want to distinguish based on that, and then they also publish all this data to their UI dashboards also. That's a separate thing. They use Tableau for this. I'm not going into that, but they have the dashboards where they keep on reflecting in the form of analytics, and they kind of monitor all that. So that's what sort of similar thing I've also given you. So you can try this up. I've written down a lot of codes actually for you. So you have to just go ahead and basically look at it, execute it, have fun with this part, and try to create your own applications. Spark streaming is really very powerful thing actually. When you're working with it. And right now, I have given you just a normal size data set of log, though it's not very small also. It's pretty huge if you keep on going around. But what happens in Facebook and all, since their application is running, they keep on generating those continuous logs. So let's say that Apache Tomcat, they use Jetty actually, but let's say the Jetty is running or Apache Tomcat is running. So it keeps on continuously generating log. Right? It don't stop. So that's where the streaming concept plays a role. You're streaming it and bringing the data. But they don't use for this Kafka, because for logging and all, you don't struggle with like losing the data. Generally, the losing of packet happens when you're bringing it over the internet connection. So that's where basically you have to connect with using Kafka. Everyone clear with this? I hope everyone is getting a very strong insight about Spark streaming now. Any question from anyone on this? Okay. Now let me start talking about Spark ML. So first thing first, when we say ML, I know few people yesterday told me that they don't know anything about ML. So just to give you a quick insight on that. So what is machine learning right now with us? Think about machine learning like just like we as a human. What we are doing is, from childhood, when we were born, we do not know anything about any aspect of the things. And what we did was, we learned from our school systems, from our friends, from our parents, from all the environments what we got. And today, whatever learnings we have done, we are improvising on top of it. Even this training also what we are doing, what is happening right now, you are learning it from someone. And once you will learn this, you will run your learning on some new project, which may have some new challenges also. Maybe it would be having some more things where you need to even train yourself more across that, because technologies also keep on upgrading on its own later. So here we are doing, what we are doing is we are getting trained first, and based on that training, we are also able to now getting exposed on some new sort of problems around the same thing, right? So definitely the project you will be working will be around the big data, not going to be something different. It's not going to be that you will get physics problem. Right? It should be around the same thing what you have done. So we are also a kind of a ML. Now, same way, even on the systems, if I can make my system learn something, and then using that learning, and how I'm going to make learn, just like we as a human are learning from some inputs, like I'm currently the input for you, right? I'm giving you the data, uh, of all the techniques to basically go about, right? So this is a data. Similar way, when machines also learn, they also need the data. They need some data details beforehand so that they can perform some operations on top of it. So that technique, what we basically placed up, whatever learning we do, and then when we give a new data to it, that's once it learns, it is able to predict that what is going to happen for the future. This is all the ML things works. Now, if you do mistakes, like as a human also, you will, when you will start working on the new project, you will do mistakes. That's obvious. You will get something new, you will try something, maybe you will fail, then you will start looking out, you will again train yourself. You will go back and start looking at Google, maybe some criteria you will get, you will ask your senior, you will again train yourself with that data and again apply it, and then again you will succeed with that. Same thing also happened with the ML concepts also. Here also, you get first train, you will apply that learning to something new on the new data set, and then basically if you fail, you will again go back and improvise yourself. So this is an iterative process which basically works behind the scene. Okay, so that is what we do as a part of your ML concepts. Very simple, creating a smart systems. Even this robots is an example of your AI only. Think about another case, like you might all be using Gmail. When Gmail came into the market, at that point of time, Gmail, they introduced the spam email box because a lot of spam started coming up. At that moment, there were a lot of mistakes used to happen into the Gmail system. That sometimes a lot of spam emails used to go to the correct emails or vice versa. Right? That used to happen in that case. Slowly, what happened? Gmail, which basically Google team have improvised on top of it. So what now it's very rare that your genuine email will go to your spam box or vice versa. It's a very, it still happens, but very rare now. So now they have, what they have done, their machine learning algorithms have learned behind the scene with the mistakes. Because what used to happen when you used to go to spam and get the correct email, you used to mark it as not a spam. So as soon as you give that new training data that, okay, this kind of email is not a spam for me. So that Gmail automatically picks up and start learning that, okay, this kind of data, I by mistakenly predicted it, it's a spam email, but it is not. So that way, Google have improvised over the time, and those mistakes it have rectified as well for today world. So again, this is the power of AI. Now within AI, there are a lot of things. Like when we work on this structured small data, we call it as machine learning component. When you have to deal with some complex systems, let's say you deal some images, videos, time series kind of data, that's where you need to go a little complex beyond it. That we started terming it as deep learning. Okay. The third component which came up is NLP component, where you mainly deal with the text data. So like you are getting, let's say tweets. Tweets is a text data. Now, definitely doing sentiment analysis and all that is very, very basic in NLP, but you can build using your basically NLP, even the all these chatbots. Like if you look at the Alexa, right? All these systems are the part of NLP. In fact, they are a combination of deep learning and NLP together because they use recurrent neural networks and all that and get you the results around that. So these systems, these three components majorly have sort of dominated. Now we also have something called as reinforcement learning. That's where you learn it from your environment also. But yeah, majorly right now, if you ask me, these three are dominating. One is a machine learning, second is a deep learning, third is a natural language processing. Now, all these three are supported inside your Spark environment as well. Now, what is the challenge which started happening? If you have limited data, fine, you can perform all these things using your NumPy, Python and all that, which is perfectly fine. But as and when things became advanced, at that level, when I say advanced, your data increase, you have to deal with unstructured data, a lot of things started coming up. That's where people felt the need of running all these side of the things in a distributed system environment as well. And that's where they introduced this library, just like NumPy is a library, Panda is a library, right? SciPy is a library, TensorFlow is a package library, right? So similar way, even Spark MLlib is also a library and package, nothing other than that. But it just make your data introduced now to the distributed system. So now your whatever you will do, it will basically get your data into different systems and get you the results in a smarter way. Right? So on a bigger data set also you can do it. Earlier also people used to work around it. When Spark MLlib was not there, still people used to work around it. But what happened afterwards was that people have to work with the basically sample of it. They used to take sample of data and then they used to perform this. They used to create models with that and they were happy with this. But now, given that we have this distributed system power available with us, definitely we should not be looking forward for doing any such things. We should be taking our whole data. We have the distributed systems that will help us to finish off all these things with the whole data itself. Thus, we can have even the better modeling systems. So that's where Spark MLlib became quite famous. In fact, Spark MLlib initial level was supporting only very basic algorithm. Maybe tomorrow I can bring up some more components around that to give you some idea, because that's something which is now getting started asked by a lot of clients. So what I'm trying to convey is basically they came up with something. Now basically we also have Hadoop 3.x, right? So in Hadoop 3.x there are some changes which have happened. That changes basically is making the AI much more stronger. I will talk about this maybe tomorrow. Not going into depth, but give you some insight that what are the requests coming from client where you cannot go with Hadoop 2.x. You have to go with Hadoop 3.x only if you want to have better AI algorithms on top of it. And this request have already started reaching to me now quite a time. A lot of companies, if I again have to take Facebook example, they also started using it. Okay. So a lot of my clients have started asking for some components which are coming from Hadoop 3.x, but let's discuss it tomorrow. Hadoop 3.x also have some more advantages where you will not directly get to know, but the client will ask you. They will say, hey, I need this. Do you think Hadoop can help me with that? And that's where if you know Hadoop 3.x, you will be able to kind of answer that. Yes, we can do that. You have to just change the setup and things will start working for you without any trouble. Now, anyway, I will come to that tomorrow, that what exactly are those components I'm talking about. But this is one thing is that when Spark MLlib started, initially it was on the RDD base. Everything was RDD base. It was also called as Spark MLlib. Okay, MLlib. Now what happened? They have changed everything to the structured data frame format. Because when you work even in your ML, you create tables, right? You work on the tabular data and using that you used to create your data frames. People who are coming from Python background, they might be aware of the data frames in Python. People who have not gone through that, don't worry about it. It's again the same data frame what you have seen in Spark SQL also. Tabular format of the data. So that data frame became the de facto, and now nobody uses RDD. In fact, that whole project have gone into the RDD base of the project have gone into the maintenance mode. Nobody kind of developing and anything on top of it, because the basically this data frame part of the things are much better. This is called MLlib, and we will be also talking about the same thing. Okay. Now, like I said, if you want to go in little more depth, you can, when I will talk to you on Hadoop 3.x, I can tell you from where you can read also about it. That's where you can do some more advanced operations other than this just data frames. Let's talk about that maybe at that time. Okay. Now, so this is one important thing why Spark MLlib became famous. In fact, right now the situation is, if I have to tell you from my personal experience, almost if I'm working with companies, let's say if I give you a random example of let's say 20 companies where I work with Apache Spark, or sorry, I am working with AI, then out of those 20 companies, 10 companies are preferring to do it with Spark ML because of the data size. And this is becoming popular now. Earlier it used to be Mahout. Mahout was becoming slow. That's the reason now Spark ML will have taken over, and those people are preferring to do their job of analytics using Spark ML. Okay, that's the power of this, and slowly this is increasing only. So right now it's 50%. Slowly it's increasing because every company wants to take the advantage of it. Not only just on a bigger data set, even if you have, let's say, a medium-sized data set, that's where also you will get a better performance from Spark because of in-memory computations. Plus, a lot of advantages what you get from the Spark. Right? A lot of optimizations are there, a lot of activities which you can do it from Spark ML itself. So that's where it became more popular. Not only this, even Spark ML can also be integrated with your normal Pandas NumPy as well. Okay, so you can basically write your code in NumPy Pandas, and you can whatever data frames you got from there, you can transform it to the Spark and do your operation. That also a lot of people do. Why a lot of people, even I do this. So basically we do a lot of activities like, let's say if I have to plot the graph and all that, that's where Spark is not good at, right? So for Matplotlib, Seaborn, people who are from that background must be aware of it. People who are not, think of them as like a visualization aspects of the things. So what I used to do, I used to like create all these things in a NumPy Pandas, do some operations, do all the cleaning components and everything, and then transform that data frame to the Spark data frame and start working. Okay. Then I start doing the processing on top of it. So even this combination is working really well and becoming very, very powerful as well. Okay. So these are a few things which you are getting it out of box from the Spark side. Plus, since this are sort of very well integrated with it, this is becoming much more popular. Now, companies are specifically targeting people for that. For example, if we talk about Azure have the Spark ML already sort of inbuilt with it. You go ahead and just write your code in your Spark ML, and you can easily even productionize it very well. Right? All these things these companies have started providing as well. Similarly, if you go to your GCP, which is the Google Cloud platform, that's where they have started giving this with TensorFlow. They have made it very, really very strong. And you need not bother about behind the scene, whether it's Hadoop 3.x or Hadoop 2.x and all that. So they take care of all the activities for you for this. So these clouds have also started enabling Spark ML as default items within them. So that's becoming because of the popularity of this. So that's where learning about this component becoming critical, specifically for the data scientist kind of people who want to do that. Definitely, you can also do all your operations here as well. You can do data cleaning. It's just that for the matplotlibs and all, it's not that strong, but you can do all the operations. I will show you some code also, how we can perform all this. Now, there are two kind of ML things. One is a supervised learning. Second is the unsupervised learning. I'm just very quickly going to walk through it because tomorrow I will just show you the code quickly in the start of the class, and then we will move to Kafka. Now, what is supervised learning? Supervised learning already have some training data available for you with the label output. For example, let's say there is a kid who is just some 5 years old or 6 years old. He's a smart kid. Now to that kid, maybe what you did, you have a Lego block. I hope everybody know what is a Lego block. Basically, it looks something like this. These are your Lego blocks, right? Kid plays with that and can create various shapes from it. So maybe what you did was you basically created a shape of, let's say, houses. You create like multiple house shapes, Lego, and you're telling it to the kid that, okay, this is the house. Sometime you created the small house, big house, hut type, different shapes of house, and you keep on teaching that kid that, hey kid, this is a house. Similar way, what you did was you created maybe another item, which is, let's say, this time, let's say like a robot. Okay. Now you created different kind of robots from these Lego blocks, maybe small robot, fat robot, thin robot, a lot of different types of robots, and keep showing to that kid that, okay, this is a robot. Now what you did, you created maybe another shape where maybe you have created a house, but you have not told to that kid that this is a house. But you are asking that kid, hey kid, can you tell me what is this? Now with the previous learning that kid have done, he will be able to tell that, okay, this looks like more of a house shape, and he will say that this is a house. You create a new item, which is, let's say, like a robot shape. but you're not telling to this time to the kid that what is this, but you're asking that kid what is this. From the learning it have done, it will be able to most likely tell correctly that it's a robot. This kind of learning is called as supervised learning. So when I said label, this label is nothing but, earlier I told you that okay, this shape is robot, this shape is house. So that house and robot was labeled earlier during the training time. That's a training time when you are telling to that kid. And by asking that kid, you are not telling that label, you are asking and looking at the shape, property, and all that, the kid is able to automatically predict that what is going to be the label for it. This is the idea behind the supervised learning. Talking about the unsupervised learning, the same example, the same kid, this time I'm creating various shape of house. Let's say they are all lying on the floor. You are creating various shapes of the robot. They are all lying on the floor. But this time you're not telling to the kid that this is house, this is robot. You're not giving any label to the kid. But you're asking that kid, hey kid, looking at these shapes, will you be able to separate them out? Means, can you bring all the house type of properties together? Bring all the robot type of properties together. Now, looking at the properties of them, the kid mostly will be able to separate them out. Still, the kid will not be knowing that, okay, this is a house side or this is a robot side. But just with the similar properties, it will be able to separate them. That is called as unsupervised learning. Clear, everyone? People who were not aware of ML, are you clear on this part? I know I told it very speed way, but
Yeah,
are you clear?
Shivang.
So in supervised learning, we have various algorithms. For example, we have regression, classification. I will talk about that tomorrow with some code. And in unsupervised, we have something called as clustering. Okay, what is all this? Let me quickly talk about clustering example. So let's say you go through this Google News, right? So you all be aware of this Google News. I can type it and show to you. Google News. Okay, look at this. I can go here. So in Google News, what is happening? You can see that this is one news like Switzerland, Ireland, 7 EU nations approve Covishield for the travel entry. Now this is coming from Times of India. This is coming from Indian Express. This is again from Times of India News. So everyone may be giving the separate topics for it also. Okay, means definitely they are all talking about the same news, but in their own way they have reported. If you look at their summary statement, there's difference in all the centers. But what Google News is able to do, it is able to bring those news all together. It is able to identify it as a common property that they are talking about, that Europe nations have approved basically the travel with the help of Covishield, basically vaccine which is here, right? So they're all talking about the same thing, and Google is very smartly able to bring up all these things together. Similarly, if you look at this one, so maybe this news is reported by these two. Similarly, you can see this is reported by one, and so on, right? So whatever common news, it is able to bring them together. You can see again, this have all the components and so on. So this is all Google News able to do, and that's called as clustering. Okay, again an example of unsupervised learning. Clear? So what I will do now tomorrow, I will quickly walk you through maybe some code. Like I said, I will give you more on the code part, which you have to do it together. I will show you just one or two codes here. And then after that, maybe I will not ask you to write the code tomorrow because we have to quickly finish this topic. But I will give you a lot of code after that to practice. Okay, it's all running code. I have already made this ready. I'm just writing right now Kafka code a bit. Most likely by tomorrow morning, I will be ready with that. I will give you that. So if I have to just talk about the class topics, that is already with me, but I want to give you something extra so that you can keep practicing on the Docker, and you can play with Twitter, you can play with even Elasticsearch, keep on sending your data, keep on bringing your data, whatever you want. So it will become like a homework for you at least with all the code ready. Okay. So that is what I will give you tomorrow, all the stuff. So even MLlib as well as Kafka I will give you. One more thing I will also talk tomorrow quickly is, because this thing came up very recently to me. There is a company uh, for whom we have saved huge amount of money by just doing some changes. Okay, by just doing some changes. In fact, our whole consultancy cost also, more than 50 times of that cost they have recovered by just that small optimization. How that optimization works. And I have noticed this sort of big problem with a lot of companies as well. This is, I'm going to talk about the storage side, because we are storing the data now, petabytes of data. So how to think about that optimally storing it is also important. Very quickly in 10 minutes, I will tell you that, so that in case if you come across that situation, you should be also able to fix it. Okay? And the client will be really surprised and happy to see all this aspect. And definitely you will get a lot of praise for these things. Okay. So I will keep bringing some things from my experience so that it can be helpful, along with the Kafka and MLlib component, which we will talk tomorrow. Great. So this is it for today, class. Any questions from anyone? I know we are already 9:30 now, but any questions?
Shivang, do you have any plans on extending this session on Sunday?
No, Sunday I will not be able to.
Okay. Okay, I see like there are various topics that you need to cover tomorrow. So if that doesn't happen, how do we take it forward?
So whatever we have discussed, Garish, we will be covering. That all will be anyway covered.
Okay, fine then.
Yeah. Like we discussed, like we just need to understand how Kafka works, how Kafka Connect works. Right? So these two topics, as we discussed, we will be covering that. Apart from that, whatever is there, this optimizations and all is extra, which I will be talking about.
Okay.
But like I said, Girish, though we can talk it out separately if you wish to. If you really want to go in Kafka in depth, then definitely there should be sort of a proper training on that, because that will help the candidates to really look at the project perspective. Because in the time tomorrow, I will be only be able to tell you maybe from an academic point of view that, okay, this is how Kafka works. I will show you a code that running it up. Maybe I will show you how Kafka Connect works. I will show you the code with that, and fine. But again, if you want to learn it in the same way how I have shown you, maybe the Apache Spark with some case studies and all that, and going little beyond some extra component, then definitely this do need, in my opinion, Kafka should be minimum of 2 days, but at least 1 day complete training should be good enough for Apache Kafka side.
Okay, Shivang. Let me have the discussion internally and I'll get in touch with Lakshmi.
If you want, you can include me in the call also. I can give you even more details, and then we can plan up whatever way you want.
Okay. Okay, Shivang. Yeah.
Sure, guys. So this is it then. Let's connect again tomorrow. Thank you, everyone.
Thank you.